This video is an introduction to what is pseudocode. It's intended for students who have already done the equivalent of CSC 142 and Intro to Java and are now going to be doing 143. And in particular, this is in reference to what I've assigned as Programming Project 0, which is a review project of 142. It's a menuing system. But I want to talk more generally about pseudocode so that anyone could use this. I, in my course, always like to have people write pseudocode before they turn in real code. And the reason why is because I've seen far too many students who have crashed and burned while trying to write their programs. Maybe they were just a little bit off, or maybe they had created a huge amount of code and then only at the very end I can see that there's a major problem. So to solve both of those, I like to see pseudocode up front. And pseudocode will let me be able to, well, first it lets you really work out the structure quickly and get your ideas down quickly. It lets me spot the flaws early. It helps you write your code. And if you, for some reason, can't figure out the pseudocode, the way to make this problem, then I can actually give you the pseudocode, and then you can just have the task of writing the real code. So if you are curious what is pseudocode and why do I not know anything about this, I can first bring up, this is the VitalSource bookshelf online version of the Building Java Programs, and in every single chapter of the book it actually has pseudocode. And you probably did see it, even though you may not have paid too much attention to it. Let me actually bring up the chapters that are relevant here. So this is actually inside the book. What I've done is I've searched for the term pseudocode, and you can see that starting in chapter 2, there's tons and tons of references to what pseudocode is and how to write pseudocode in every single chapter of the book. You, however, may not have been assigned to write pseudocode, and so because of that you may still be confused as to how to actually create pseudocode. So while I do encourage you to always pay attention to what pseudocode is, to review chapter 1 through 8, I'm going to give you some very quick, simple guidelines to follow to understand what pseudocode is. So for example, here they're progressing down several levels of pseudocode, starting from very simple, draw a solid line, draw the top half, draw the bottom half, draw a solid line. Also, this is a good example to show you that there is no one correct pseudocode. Pseudocode is actually a method of refinement. You start with a very simple solution for a problem, such as drawing this figure here. You start with a very simple solution, then you start writing some more details, and eventually they actually get into the code here. I don't want to actually get into the code. I want to stick with very simple pseudocode. So I'm going to give you a different problem than problem 0, and I'll show you how I solve it in pseudocode. So here is a different problem that I want to propose as a sample problem. So this is going to be a console-oriented program that'll ask questions and then figure out whether your object has what type of object it is for a 3 or 4-sided object. So for example, this is an input-output trace. This is not pseudocode, okay? But if what it's going to do first is ask how many sides are there, 3 or 4. If the user responds 3, then it's going to go down this here. It's going to ask to input the side lengths, and then if there are 3 of the same sides, it should spit out equilateral. If it's 3 different sides such that the Pythagorean theorem is satisfied, a squared plus b squared is equal to c squared, then it should tell you it's a right triangle. If 2 of the 3 sides are the same, it should tell you it's scalene. If there's 3 different sides, it should say it's isosceles. Oh, sorry, those are actually reversed. Got that wrong. Isosceles and scalene. And then if there are 3 sides that can't possibly exist because the sum of 2 sides here, 1 and 2, is bigger than the 3rd side, then it must be invalid. There's no way you could draw a triangle. And then if it's 4 sides, if it's a square, then I want to ask what are the lengths of any 2 adjacent sides. If the 2 sides are going to be equal, then I know it's either got to be a square or a rhombus, and I'll ask what the angle is to figure that out. Otherwise, I will ask, so if it's not the same two the same sides are the same, then I know it's got to either be a rectangle if it's a 90-degree triangle, or it can be a parallelogram or a trapezoid, depending on whether there are two sets of same length sides or not. Okay, so that's the problem. Now, how do we write pseudocode for this? So the whole point of pseudocode is for you to work out the problem. Okay, work out the problem from your side of it. And the whole point of pseudocode from my side of it is to see that you did work out the problem and that you understand how you're going to code this. Okay, so let's take a look at, if I was going to write this program, let's take a look at what I would want to do. To me, it looks like, well, there's really two completely separate things here going on for 3 sides and 4 sides. So I probably want to have 2 separate methods for whether it's got 3 sides or 4 sides. And the main would probably, I typically like to have main do as little as possible. I would probably typically call a function from main and not actually put any code in main. But this program is so simple, I think I would go ahead and ask in main this 3 sides or 4, and then send you to either this routine or this routine. Okay, so let's start with that. I've got some code, pseudocode already written here. So I've got a main, okay, that is asking how many sides are there going to be, and then it's going to send you off to 3 sides or 4 sides. Okay, and then you've got a 3-sided function here. You've got a 4-sided function here. Okay, I'm going to go ahead and expand this window now that we're getting more code. So one of the things that should be clear from your pseudocode is, what is the structure of your program? Okay, this is really the main structure of the program. There's a main, 3-sided, 4-sided. Okay, now there are a few more routines that I've written down here. I'll get to those in a little bit, but that's really the main thing. There's 3 functions, and you see by using this indentation that it's very clear to understand that I've got 3 different functions here. Okay, so now let's take a look at what I've got in main here. So I always want you to put any arguments. Okay, I skipped them for main just because they're always the same. But here, for example, I'm putting this argument here and this argument here. And I also want you to put what are the return values, and make sure you handle those return values. So I'm not doing anything with these, and so these are void. Okay. Now, so I set up a scanner here. Now, in general, I don't like to have any code. Okay, I'd rather have English. So I could have said sc equals new scanner on system.in. Okay, but in this case, I really think that this code here is just as clear. Okay, but in general, I don't want to see a lot of code here. Okay. Little exceptions are like these equals and the double equals, if, then, else, etc. Those are all very simple pieces of code that actually help me read code quickly. So it's okay to use those. But you can see how simple this is. Okay, so you notice I've got this ask sides here, sc. So of course, as you might imagine, I'm going to need to actually write a function, ask sides. Let's do that. It looks like I didn't actually get around to that. So I'm going to have, it's going to be an int return, ask sides, taking a scanner sc, and this is going to print, how many sides? 3 or 4. And then return sc dot next int. Okay, so again, I don't want to put a lot of code here, but you know, if I wrote out in English, return the next integer from the scanner, that's actually longer than this, and this is such a common piece of code that it's easier to read this than if I wrote that all out. Okay, so we've got the ask sides if the sides equals 3, otherwise if the sides equal 4. So here's my function for 3-sided, taking the scanner. Okay, I print out what I'm going to print out. So this shows me that I'm going to use next int on the scanner to get those 3 integers. Now here you'll see a couple different ways of doing code. Okay, so now this is a lot of code here, and you tell me, does this is that really easy to read, or maybe I should have just said all 3 sides equal. Okay, that is actually easier, and that's really the preferred way to go. Just say that. It's pretty clear what your code is going to eventually be. If it's something where you really need to figure out how you're going to make test all 3 sides equal, okay, then it's fine to go ahead and do what I originally did here. Side A equals side B equals side C. Turns out that's all you need to check. You don't have to check if side C equals side A. But again, the emphasis is on making things easy to read, okay? So if that's the case, then equilateral. Else, if it's a right triangle. So I started out by saying a squared plus b squared equals c squared, but then I quickly realized, you know what, that's not sufficient because we don't know which of the 3 sides are a, b, and c. So I ended up actually deciding, you know what, I really need a separate function, right triangle, where I input the 3 sides. And then now I could have, down here, I could have said, okay, if a squared plus b squared equals c squared, or b squared plus c squared equals a squared, or c squared plus a squared equals b squared, but it's obviously a lot clearer if I just say try the Pythagorean theorem on all 3 possible combinations, okay? And I made clear to return a Boolean, and that goes back up to here, right triangle, okay? So again, clarity, 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 okay? As long as, you know, if I name this function here foo, that's not very clear, right? So right triangle, it's important that this actually clearly indicate what is going on, okay? Here I say if any 2 sides are less than the third side. Again, I could have written out something complex, more complex, that has to test each of the 3. And maybe in the end, I actually end up writing a function kind of like this one here that tests each of the 2 versus the 3. But again, the point is it really clear to read? Finally, I tested to see whether it's isosceles, and if it's not isosceles, then I'm gonna put that it's scaling. Okay, so that was the 3-sided routine. Then the 4-sided routine. So I'm going to print out. I'm going to get the 2 sides. I'm going to add. Now here's an interesting choice. So I could have just called squarish and non-square, and then asked inside of each what is the angle for the vertex. But I realized when I started writing this that, you know what, both of them, the very first thing I do is ask what's the angle. So through this pseudocode, I realized it's much more efficient to put that here. And that's the kind of thing I want you to figure out and put in pseudocode, okay? So rather than repeating it twice, I've only done it once. And I get that angle now, and now I actually pass it in. Okay, so that's another important thing in pseudocode. I want to see what are your variables, okay? And if it's not a void, what are you doing with the return variables, with the return values, okay? But in this case, I can just check to see if the 2 lengths are the same. If so, I've got this function squarish for distinguishing square versus rhombus, or I've got this non-square, and it's a little bit more complicated where I have to actually, if it's not 90, then I have to get all 4 sides. And again, I said like if 2 equal pairs, okay? So again, I could have written a routine. Maybe I have to in the end to test, since I don't know which of the 4 are which, I have to test whether the 2 pairs are equal. But so let's just put it in English, 2 equal pairs, okay? That's very clear. Otherwise, trapezoid. All right, so that's an example of what pseudocode is. Now, let's pull this out to some very simple guidelines for what pseudocode is and isn't. Okay, so here are some guidelines that I think should help you write pseudocode. The primary purpose, and this is the most important thing, the primary purpose of pseudocode is clarity, okay? It's not correctness, it's not syntax, it's not to write something that's really big, it's clarity. You want to write something that is clear as possible. That is the #1 most important rule. If you write something that's clear, it'll be great pseudocode, okay? If you write something that's perfect but very hard to read, that'll be terrible pseudocode, okay? I want to be able to quickly scan it and be able to understand the flow, so I need to see those function definitions. It has to be easy to spot problems, both for you and for me. So for example, when I was writing that pseudocode and I realized I was going to have to repeat that print statement as the first thing in 2 functions, I realized then, you know what, that's redundant. Let's pull that out, okay? That's the kind of thing you want to spot before I have to spot it. All right, please use English, not code. I have seen people who actually created their own basic programming language thinking that that was easier than English. It is not easier than English, okay? Certainly, I can read code, I can read English, I cannot read your created programming language. So use English words. In fact, don't use more than 7 words in any one line, okay? If you are using more than 7 words, you're getting too complicated, okay? Make it simpler, okay? So there are exceptions to using code if it makes it clear to use code, such as equals, double equals, if then else, for. Okay, those are all going to be easier than just trying to write English, okay? Don't use comments. If you're creating comments or putting every line in a comment, that's going to make it harder to read, okay? Comments should not be necessary in pseudocode. Pseudocode should be so easy it's better than a comment. Using indents helps me identify what your structure is. Please don't use brackets. That just adds more complication. Again, English, English, English. Do show your variable declarations, okay? Both the locals and the parameters. Do show all functions. That was implied by the indents. Your arguments and return values. That's the variables here. And make sure you handle all those return values. It's okay to be vague, okay? As long as you explain yourself. So 2 of the 3 sides must be equal. That's very clear. There's no question as to what the intention there is. Now, it may turn out that you can't figure out what the code is there, but at least at the pseudocode level, I understand what it is you're trying to do. And you understand too. Hopefully later you figure out that you actually have to do A equals B, or B equals C, or C equals A. But that's not the most critical thing for pseudocode. The most critical thing is that you understand what the problem is that needs to be solved. Shorter pseudocode is better than longer, okay? Really, ideally, every assignment that you'll receive in this class can be done in less than a page of pseudocode. We won't argue about exactly how many lines are in a page, but really, you don't want to be, I don't want to be paging through multiple pages of pseudocode, okay? If it's getting long, then simplify it, okay? And another guideline is, can a stranger, not you, but a stranger, read your pseudocode and write code from it, okay? You want it to be clear to other people, especially me, what it is you're trying to do. So those are a few guidelines for you that I would like to see. I've seen lots of people go wrong with pseudocode. I've seen people who tried to just give me the text input and output. That is not pseudocode. I can't tell whether you know how to solve that problem. I have seen people who gave me 2 pages of commented code. Okay, that is not pseudocode. It's hard for me to read all of that. You can have bugs in that. It's not what I'm looking for. I've seen people who just turned in code. Again, that is hard for me to read and look at, and you're not going to get credit for pseudocode. I want to see that you, ahead of time, actually had a design that you wrote down, not that just you could have easily just gotten code from somebody else and turned it in. Okay, I want to see that you actually understand how to write the problem. All right, so these are all guidelines, hopefully, that will help you write pseudocode. And again, pseudocode should be a helpful thing for you and for me. So good luck on writing your pseudocode. I will try to give you feedback when you turn in your pseudocode, but these guidelines I think should keep you pretty much on track. All right, thanks very much and good luck on your problems.